Hello, Professor. My name is Zhang Junjie. This is the differential equation final project of Group 4, and I'm going to talk about how our topic of this project came up. We have thought for a long time, but didn't have any idea what we're going to present. Thus, we try to review what we have learned in high school, and motion of string occurs to us. Thought other motion patterns might be easier than this, but we think we have more things to discuss about this motion than others. So we decided to choose motions of swing to be our topic. After that, we decided to talk about the effect of thermal expansion on pendulums and the errors in measuring time.
Hello, Professor. I am Yu Bo Zhao. To talk about motion of swing, we can first look at the basic formula. This, which T stands for the period of a motion cycle. L means the length of the line. G means the constant of gravity. In this formula, we could find that L varies directly with G, while G being not identical in different places, such as North Pole, equator, and the Moon, and the relation between L and G is what we are going to focus on. To reduce the error of the length of the line carrying a weight, we must consider the temperature and the weight. Because temperature is a factor that influences L, as well as the weight. Due to different weight, that line should hold on. The formula for these two factors are this and this one, which alpha means the coefficient of thermal expansion, T means temperature, K means coefficient of elasticity, and X means the expansion of the line. So, we can find that both temperature and the weight can affect L.
Hello, Professor. My name is Lai Xiaoting. I'm going to talk about how factors L and G can affect the period of a pendulum motion cycle. First, let's talk about G. Let me show you the equation for G. G equals G0 multiplied by 1 minus 0.00265 cosine end divided by 1 plus 2h divided by r, where G0 means Earth's standard gravitational acceleration, which is 9.80665 meter per square second. And is the place's latitude. H is the place's altitude. And R is Earth's average radius, which is 6,370 kilometers. From the equation for G, I choose 5 places that may represent different factors which affects the value G. They are Taiwan, the equator, the North Pole, the Himalayas, and Netherlands. Why I choose this place? It's because Taiwan is the place we live. The equator has the lowest latitude on Earth. The North Pole, on the other hand, has the highest latitude on Earth. The Himalayas has the highest altitude on Earth. And Netherlands is just a representative for countries that is lower than the altitude 0. After our calculation, we'll get the value. The value of G for Taiwan is 9.78901 meter per square second. For the equator is 9.78033 meters per square second. For the North Pole is 9.83 meters per square second. For the Himalayas is 9.790490079 meters per square second. And for Netherlands is 9.756511494 meters per square second. Next, let's talk about L. The equation for L, I believe, Yu Bo has shown you. I remind you again. L prom equals L multiplied by 1 plus alpha t. From this equation, we can see two factors, alpha and t, that may affect the value of L prom. So, we're going to take the same 5 places that we choose for G to determine the value of L prom. We will talk about the factor t first. For all the t, we take the yearly average temperature into consideration. And for all the value of alpha, it depends on the material we select for the line. In this case, since we are going to talk about the variation of t that may change the value of L prom, the value of alpha cannot be different. The material we choose for the line is copper, whose value of alpha is 16.5 ppm per degree Celsius. In this way, after our precise calculation, the value of L prom equals to 1.00040785 meters for Taiwan, 1.0043725 meters for the equator, 0.999967 meters for the North Pole, 1.0001716 meters for the Himalayas, 0.999571 meters for the Netherlands. This time, we'll change only the value of alpha with the same t, which I choose Taiwan. For alpha, we select tungsten, iron, and silver, which respectively is 4.5 ppm per degree Celsius, 11.8 ppm per degree Celsius, and 18.9 ppm per degree Celsius. In this way, L prom becomes 1.000109305 meters for tungsten, 1.000286022 meters for iron, and 1.000459081 meters for silver. That's all for how values of L and G can affect the period of pendulum's motion cycle respectively. Now, allow me to introduce Zhuangbo Xiang, who will talk about the Python program and its simulations.
Hello, Professor. I'm Zhuangbo Xiang from Department of Civil Engineering, and I'll explain how this program works. So in the first section, we can see many constants here, and G means the gravity constant, theta means the angle of the pendulum, and the 30 means 30 degrees, and we'll change it to the unit or the unit radius. So we times pi 30 over 180, and d theta means the change of the angle, L for the length of the line, and t for time, and dt for the change of the time. And the second section is these object, the point on the top, and the string, and the ball. And the top is means the top of the string, and we use a sphere to display it. Yeah, this is a small sphere, and the position of the top is L is 0, L over 2 and 0, and we use that because we want to make the pendulum in the middle of the screen, and the radius of the sphere is 0.01, and the ball we also use a sphere, and its position we use the position of the top and and plus L times sine theta, negative cosine theta, and 0, and we can get the position of the ball. And the radius of the ball is 0.05, and it's blue. Yeah, and it will leave the trail behind it. And the string, we use a cylinder to display it, and the position means that it will swing around the position of the top, and the axis means how it will expand on what direction. So it expands on the position of the ball and the position of the top, and its radius is 0.01. And finally, the while loop, and t less than 3 means that it will display for 3 seconds. Well, that's 3 seconds. And rate of 100 means that how fast it will display. So 100 is 100, it will display in 100% speed. The purpose of these sections is to update every variables in the first frame to the other frame. So according to the equation of the pendulum, we can get the double d theta equals to negative g over L times sine theta, and we will update the double d theta to the d theta and theta, and also the t. So in the next step, we will update the theta to the position of the ball and the string, so we can see the next frame, the string on the next frame, and it will move eventually.
And now we're going to substitute different constant of gravities from several places. And the first place is Taiwan. And the second place is at equator. The third one is at the North Pole. The fourth is in Rotterdam. The last one is in Himalayas. And the next two parts I'll directly substitute different length from the conclusion and the calculation from other teammates. And set the constant of gravity into 9.8. And that's the result of our simulation.
The website below is the reference what we take while doing the final project. And this is the end of the differential equation final project of Group 4. It takes much of our time to check the data and try to simulate the pendulum. Thanks for watching.